Hello everyone, welcome again to Let's Crack JEE in English, the channel of Unacademy. So let me check first whether I'm live or not. So in this session, we are going to continue binomial coefficients series. That means series involving binomial coefficients. So we'll try to cover all these series. Yeah. Also, let me check my voice. Where's the... Wait a minute, guys. Right, so we'll continue this session today. In this session, I'm going to do binomial coefficient series. All right, so let me check my voice. Seems hello, voice check. Yeah. All right. So basically, what we are going to do in this, we are going to cover all the binomial coefficients, all the series of binomial coefficients. So I'll tell you all the methods which we are going to apply, which actually we apply in binomial coefficient series. All right. So we'll do all these things. We will begin in a moment. Just give me. All right. One moment, guys. We are starting. Okay. So before we begin, first let me introduce myself. I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been mentoring IIT-JEE aspirants for last 11 years. I have worked with various national level institutes in Lucknow, Delhi, and Mumbai, and I teach mathematics. And I joined Unacademy a few months back. So I'm taking sessions on this channel for all the students who are preparing IIT-JEE in English. All right. So we were doing. This is a special session I have kept for binomial series of binomial coefficients. This is a very important part of binomial theorem, and today we are going to cover a lot of series. I'll try to cover as many as possible. All right. I'll also tell you the methods, and then we'll practice a lot of questions. But before the beginning, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform, and you can prepare for IIT-JEE or NEET or many exams on this platform. But here, let me talk about IIT-JEE. So if you are preparing for IIT-JEE, and then you can take plus subscription of Unacademy, and iconic subscription is a new thing which is added recently. So I'll tell you about iconic subscription also today. So first, let me tell you about the plus subscription, and many things are free also on the platform. I'll tell you about those things as well. One moment, guys. All right. So first of all, plus subscription. So if you are taking plus subscription, then you get daily access to daily live classes of all the JEE educators. So many courses are going on the platform. India's top educators are taking courses. So you can access all these courses once you take the subscription, plus subscription. All right. You can watch their live sessions as well as recorded sessions. And all these sessions are well structured, pre-planned, everything. You can see this course is going on calculus, this course is going on for class 12 full mathematics, this course is going on coordinate geometry, and a revision course. Every course you can access that. So you can follow educators of your choice. It's complete freedom you get on the platform. And this is unlimited access, we say. So this is unlimited access you get when you subscribe to free special classes and free courses as well. So you can attend these special classes. I also take special class at 4 o'clock or 4:30 p.m. every day, and I also take doubt classes in the evening 8:30. So it is tomorrow 8:30 doubt class, and 4:30 you can come for my special classes. It will be so far I was taking on AOD, complex numbers, many of the topics I have covered, and tomorrow also I'll cover one of such topic. All right. So this was about the free and quizzes. Quiz features are also there. Very many quizzes. So there are live quizzes going on the platform. So you can attend these live quizzes every day. All right. So these quizzes and special classes are free. I hope you got this. Now let me tell you the plus subscription charges. So if you're subscribing for 1 month, 3 months, 6 months, accordingly you'll have to pay 7,000, 7,000 and 500 and 28,000. But 12 and 24 months are the best, economically better packages. You can compare per month price in this. So it is 38,500 and 56,000. You can see this, right? But if you are using my code JEET1, all right, then you get instant 10% discount and you'll have to pay this much only, 34,600. So you can compare this per month. If you are buying 12-month subscription, you'll have to pay per month 2,888. And if you are buying 24-month subscription, then it is only 2,100 bucks. All right, for all three subjects. All right. So, and that too for India's top educators. All right. So this was about the subscription, which is come actually very cheaper. So if you haven't taken the subscription, then take the subscription for unlimited access, or you can watch special classes if you don't want to take subscription yet. So then go and watch these special classes and see how interactive this platform is. All right, you'll come to know. You can ask your doubt from the educators during the live sessions. Also, you can send your images. All right, you can chat or you can participate in the poll. So after all, this platform is very interactive and you'll come to know. So just watch these special classes, all right? Attend these special classes. Now let me tell you about the iconic subscription. So what is this iconic subscription? This is a new feature we have added. In this feature, you are getting, you'll get all the benefits of Plus, which I just told you. You'll get everything what I have just explained in Plus subscription. Apart from that, you will also get a personal coach. That means a personal expert will guide you throughout your preparation, all top exam preparations, and you will get personalized test analysis. All right, your study planner will be prepared in a customized way. All right, so this is a feature we have added for iconic subscription. So if you need this personal expert advice, test analysis, personalized way study, then you should go with this iconic subscription. So many of the students require this kind of they need some someone to always push them to they don't they need some push. Okay, so this personal coach is the best. This iconic subscription is the best thing for them. All right. Okay, and that too from an expert. All right, on a regular basis. So, and personally, let me tell you the charges also, subscription charges. So it is not very costly. It is for 12 months, 56,000, and if you use this code, then you'll have to be only 50,000. So this personal expert will be, added to this your Plus subscription, and that too with this cost only. All right, and 86,000 for 2 years, and then in that all you'll have to pay only 77,400 for 2 years. Okay, so still you can see that how so many things you're getting just by paying this much. All right. So this was about the subscription, and then you first you can download this Unacademy's learning app, and then whatever I've told you, you can attend. Just make your profile and just keep attending these special classes, and then you plan what kind of subscription you need, one Plus or iconic. All right. Now let's begin today's session. So there is binomial theorem, series of binomial coefficients. So I'll tell you some series in the beginning first. Let's start from the very basic. As we are going to discuss all the series, so I'll start from the very basic. Okay, so first binomial expansion, which is 1 plus x raised to n. This is nc0 plus nc1x plus nc2 x square and so on up to ncn x raised to n, right? This one. Which in short you write in terms of sigma ncr x raised to r from 0 to n. All right. So this is binomial expansion. So we are going to use this to find the first series, sum of all binomial coefficient. You all know this. I'm just repeating it. NC2 and so on up to NCN. So we just put x is equal to 1 in this. Put x is equal to 1 in this first equation, right? And after putting x is equal to 1, you'll get this sigma of NCR. You can write this series in form of sigma, so which is like this, and or you can expand it, so NC0 plus NC1 and so on. It is up to NCN, and what is the value? Just put x is equal to 1 in this, you'll get 2 raised to n. All right. So if you put x is equal to 1, x will vanish everywhere. You can see x will disappear, and you can see NC0, NC1, NC2, and NCN, right? So only binomial coefficients will be remaining. In fact, in any of the expansion, if you need the coefficient of a particular variable, sum of coefficients of a particular variable, then put that variable is equal to 1. In this case, binomial coefficients are the coefficients of x, right? Powers of x, all the terms. So we are putting x is equal to 1 and we get this, okay? So this is the first very important series, all right? Now the second series is if you need alternate plus minus, NC0 minus NC1 plus NC2 minus NC3 and so on, all right? Which in so short you write sigma minus 1 raised to r NCR, r from 0 to n, all right? So what is the value? In this case, you need to put x is equal to minus 1 in the same equation 1, and you'll get this sigma minus 1 raised to r NCR, r from 0 to n. What is this value? It's going to be this. Let me write this in a series form, NC1 plus NC2 minus and so on, minus 1 raised to n, NCN. This is going to be last term, and this value will be 0. All right, so this is 0. So sigma NCR is 2 raised to n, sigma NCR with alternate plus minus is 0. Okay, so this is the first very basic series, okay, which you need to remember. So both the series you need to remember the values. All right. Now let me tell you another series. This is sigma of RNCR, all right. So if you open it, you can start from 0 or 1, because if you put 0, then first term will be 0 only. So this is nothing but 1 into NC1 plus 2 into NC2. So you can see some numbers. So here we are taking the same numbers which you can see in NCR into R, okay. So whatever this number in the subscript of NCR, the same number we are multiplying. So it is R NCR, all right. So 2 and then so on up to n into NCN, okay. We need to find the sum of this. So this is our first series, slightly challenging, but if you have done it, then you know how to do it. So I'll tell you 3 methods to do this, okay, 3 methods. You can use any of the method. Sometimes first method is useful in some of the series, sometimes second, and sometimes the third one, all right. The third one is also very important. So I'll tell you first, I'm going to use this formula. So you need to remember this formula, R NCR is equal to n minus 1 C R minus 1, okay. So this is the first method and very important method, because you can use this method anywhere, the most generalized one, all right. So in many questions you can use it. This is very helpful. So first you remember, memorize this formula, R NCR is equal to n minus 1 C R minus 1, okay. You can prove it very easily just by putting the value of NCR. You can prove it, all right. So this is the very important formula. Second is property of sigma. So what is the property of sigma? If you write A to B, R from A to B, f of say R, f of R, then this can be written as sigma f of A. R can be replaced by A plus B minus R, okay. So we are going to use this property of sigma in a lot of questions today, all right. This is this property. If you have done definite integral, then you know what happens when you apply this property. Series just get flipped. That means last term becomes the first term and first term becomes the last term. If this series is f1, f2, f3 up to fn, then this series is nothing but fn, fn minus 1, fn minus 2 up to f1. All right. So some will remain same. If you start putting the values of a, b, a1, a2, a3 up to b, and in this also you'll get to know. All right. So this is also property of second. This we are going to use in third method, and second we are going to do differentiation. All right. So three methods. So first use this method. All right. So I'll start with this sigma r n c r from 1 to n can be written as sigma of, if you use that formula, r will vanish. So in place of r, n will come, and this will become n minus 1, and this will become r minus 1. While applying this formula, always remember these two numbers should be same. Even if it is r plus 1 here and r plus 1 here, then also you can apply. R plus 1 will be replaced by this number. If it is n, then it will be replaced by n. If it is n plus 1, then it will be replaced by n plus 1. And these numbers will be decreased by 1. All right. For example, if you have r plus 1, n minus 1 c r plus 1, then also you can apply. See, this is your r, this is your r. All right. So these two are same. Then after applying, this number will come in place of r plus 1. So n minus 1. You can take this outside the summation. This n minus 1 will become n minus 2 c, and this r plus 1 will become r plus 1. All right. So in this way you can apply this formula. After applying this, you can see r from 1 to n. You can take this n outside and expand this. So you can see what is this written. So it is n minus 1 c, where is this starting? N minus 1 c0. Put r is equal to 1 in this. It is n minus 1 c0 plus n minus 1 c1, and so on up to which place? N minus 1 c n minus 1. All right. You can see what is the summation of this. We have just finished it. So nc0 plus nc1 plus nc2 was 2 raised to n. So n minus 1 c0 plus n minus 1 c up to n minus 1 c n minus 1 will be 2 raised to n minus 1, because we are just replacing. So what is the answer? 2 raised n into 2 raised to n minus 1. Okay. So this is something which you need to remember. Okay. I'm writing this separately. R and CR. Okay. This is a formula. I will suggest to remember it like you are remembering the value of the first series. All right. So this is another. So before starting the practice session, I am telling you to memorize some of the values, some of the results. So this is the third result which I am telling you to memorize. All right, third result. So first two results were this. This was the first result. All right, this was the first result. Sigma NCR R from 0 to n was 2 raised to n. This was your first result, which you need to remember. This was your second result, minus 1 raised to r, NCR sigma r from 0 to n. This was 0. And now you have got one more result. It is r NCR. R is starting from 1. Even if it starts from 0, then also result will remain same, because if you start if r starts from 0, then first term will be 0. So that means you're not adding anything extra in this. All right. So series value of the series will remain same. Okay. So this was method 1, solution 1. Now see solution 2. So I'll tell you 3 methods which you can apply. So in solution 2, we are going to start with that binomial series. What was that binomial series? That was sigma 1 plus x raised to n was written as sigma ncr x raised to r. So this is method of differentiation, r from 0 to n. In this, differentiate with respect to x. All right, you can differentiate. So both sides you can differentiate with respect to x, will get n. Why are we differentiating? Because if you differentiate x raised to r, you'll get r x raised to r minus 1. After that, you need to remove x, right? So we'll put x is equal to 1 like we did in the first problem. So n1 plus x raised to n minus 1. This is very simple using differentiation, although the first method is also very important. So NCR r x raised to r minus 1. ddx you can take inside the summation. That means you are just this ddx operator you are putting to all the terms of a series. Yes, you can do that, right? because ddx of a plus b is ddx of a plus ddx of b, right? Now you can put x is equal to 1. So if you put x is equal to 1, you will get the result n into 2 raised to n minus 1 is equal to sigma. This is r n c r. R is starting from 0 to n, and you know you can put r is equal to r from 1 also, right? Because if you put r is equal to 0, you are going to get first term is 0. So obviously you can start from 1. All right, so I'll write it here. This is what I'm saying, 0 or 1. All right, here also you can write 0 or 1. So this was the second method. Now let's see the third method. What is the third method? Third method is that property of sigma. So r n c r from 0 to n. So applying that property, a plus r can be replaced by a plus b minus r. So a plus b is n in this case. So you can write r can be replaced by n minus r, ncr, all right. Let's take this is equal to I in this case, all right. And limits will remain same. Then you can distribute sigma. So it is going to be sigma n into ncr, okay, r from 0 to n, minus sigma r into ncr, r from 0 to n. Oh, I'm sorry, I have taken this r outside. No, only n can be taken outside, not r is a variable. So r ncr up to n, all right. So this part is basically nothing but I. So you can put this is equal to I. So you'll get this equation, I is equal to n, you can take outside, sigma of ncr r from 0 to n. Okay, I forgot to mention this thing, that while applying this property, this number will also be replaced by n minus r, but again you can write nc, n minus r can be written as ncr, all right. So I have written this again, ncr, all right. So that's what has been done in this. This will remain n minus r, but nc, n minus r will again be replaced by ncr, all right. Minus this is nothing but I. So from this equation you'll get 2i is equal to n into, we know the value of this, that is 2 raised to n, and then you get I is equal to n into 2 raised to n minus 1. So I hope it is clear to everyone. This is the third method to solve that series, all right. So we have got three methods. Three methods. The important point is that we need to remember its value, all right. We need to remember the value of this series. All right, now the next series is this, NC1 minus 2 into NC2 minus plus 3 into NC3 minus 4 into NC4 and so on. The same series with alternate plus minus sign. So in form of summation you can write minus 1 raised to r minus 1, actually in this case it is r minus 1, r into ncr. Okay, so if you put r is equal to 1, you'll get positive term, and if you put r is equal to 2, you'll get negative term, all right. So r from you can start from 0 or 1, doesn't matter, all right. This. So what is the answer? I'm writing the answer first. Answer is 0, all right. Answer is 0. So this is also 0. Even if the second series, if you put, sorry, in third series, if you put alternate plus minus sign, then result is going to be 0. Okay, so you can use this, use it. Okay, I'll prove it fast, and then it is going to be minus 1 raised to r minus 1 r ncr, all right. So we'll apply the formula. I'll use the first method in this case. So r ncr can be written as, you can always apply that formula if these two numbers are same, right? So yes, they are same. So you can apply that formula. It is going to be n, we'll write n outside, minus 1 raised to r minus 1 as it is. It will become n minus 1 c r minus 1, all right, and r from 1 to n, right. Now you see this is nothing but all the binomial coefficients, sum of all the binomial coefficients with alternate plus minus sign. Okay, I'll expand it for you. It is n minus 1 c0 minus n minus 1 c1 plus n minus 1 c2 and so on, right. Now you know what is the sum of this. Sum of all the binomial coefficients plus alternate sign plus minus sign is 0, right. So this is nothing but 0. So answer is 0. In fact, if I generalize it, then I can say one thing. I'll tell you one thing. This is minus 1 raised to r minus 1 or r, doesn't matter if you write r or r minus 1. It only, see, in the previous case, even if you put r in place of r minus 1 here, minus 1 raised to r, then also will remain 0. It means now you are starting the series from minus with minus sign. All right, even if you start from minus sign, minus plus, that means you are multiplying this whole equation by minus. So because result is 0, so it will remain 0. All right, it will remain 0. So let me tell you this: whenever you have this r raised to k and NCR, all right, if r raised to k is in product with NCR and you have alternate plus minus sign, this minus 1 raised to r will give you alternate plus minus sign. R starts from 1 to n, all right. This result will always be 0. This result will always be 0. Okay, so you can use this result. We have a series in which squares of natural numbers cube or cubes of natural numbers are multiplied to NCR and alternate plus minus sign, then you can use this result and answer is going to be 0. Like for example, if I write 1 raised to 4, okay, there's one condition that k should be less than n. All right, this k should be less than n. Okay, then only. All right, like 1 raised to 4 100C1 minus 2 raised to 4 100C2 plus 3 raised to 4 100C3, all right, and so on, alternate plus minus sign. What is the sum of this? If you write in form of sigma, so this is written minus 1 raised to r minus 1, right, and r raised to 4 and 100 CR. This is what is written here, right? R is starting from 1 and up to 100. Up to 100 terms, all right? So what is the answer? You can see this 4 is less than 100. Yes, you can apply. This answer is going to be 0. You have alternate plus minus terms. So got this? This is a very important one, all right? So this and the one more result, and then we will start our practice session. One more result is this: sigma of r square NCR, all right? This is again a point which you need to remember, okay? This value you need to remember. So how to solve it? Okay, first I'll write the result. Result of this is n into n plus 1 into 2 raised to n minus 2, okay? This is the result. R you can start from 0 or 1. Same thing, because first term is 0 if you put r is equal to 0. So this is a result which you need to remember, and I will solve it using that formula only. Which formula? I'll tell you. Sigma r square NCR. So this r square can be written as r into r. You can write this r into r, all right, r from 1 to n, and apply that formula. So this is going to be sigma of this first r will remain same. This r NCR will become n minus 1 CR minus 1, all right. Now how to solve it? Now further, now you can't apply that formula because this number is r and this number is r minus 1. They should be same. So to make it same, you need to subtract and add 1 in this r, okay. So I'll do that. So while doing it, keep this n outside, make it r minus 1 plus 1, all right, plus 1. And then we'll separate this summation n minus 1 CR minus 1. We'll get two questions, all right. So first will be sigma of r minus 1 n minus 1 CR minus 1. This is our first summation. And plus second is going to be sigma of n minus 1 CR minus 1, all right, like this. Okay, now I'll start from here. Then what will happen? Then you can apply the property. Now I can be written as, see, in this you can apply the property. R is starting from 1 to n, all right. In this R is starting from 1 to n. But in this you can start from 2 also, because see if you put r is equal to 1, this first term is going to be 0, right? So you can start r from 2. Like in this, whether you start from 0 or 1, it is same. Similarly in this, whether you start from 1 or 2, it is same. So after applying the formula, you'll have to start from 2. See how? If you apply the formula, which formula? R NCR is equal to n minus 1 CR minus 1. These two numbers should be same. So yes, they are same. So r minus 1 will be replaced by n minus 1. So it will be n minus 1. Take this outside the summation. And this n minus 1 will become n minus 2. See, r minus 1 will become r minus 2. All right. R will start from 2 because now you can put R is equal to 1 in this. So R will start from 2. And the logic I have told you here also. So R from 2 to n plus this you already know. What is this? There is sum of all the binomial coefficients. So that is 2 raised to, now n will be n minus 1, right? Now here also you can use this sum. This is also sum of all binomial coefficients. C put 2. It is n minus 2 C0 plus n minus 2 C1 plus n minus 2 C2 up to n minus 2 Cn minus 2. So what is this? This is nothing but n into, distribute this, n minus 1 into 2 raised to n minus 2 plus n into 2 raised to n minus 1. Okay. Now take this common, 2 into 2 raised to n minus 1 into n, take this common. It is going to be n minus 1 into 2 plus 1. All right. So like n minus 2 will be common. Sorry. Okay. So what is remaining? 2 will be here. So it is going to be 2. All right. Now this is n. This is n plus 1. And this is 2 raised to n minus 2. Okay. So this is the answer. You need to remember this value. Okay. So these are 6. This result I have already done. So if you put plus minus in this, answer will be 0. Even if you take r cube. So r cube NCR you don't need to remember, but minus 1 raised to r cube NCR, you can say answer will be 0, right? Using this. So I have told you these 6 series to remember. Why do you remember? Why do you need to remember these series? Let me tell you why. Suppose one example I'll give you, and after this we'll start the session. Suppose you have this 3 into 5 into NC0 plus 5 into 7 into NC1 plus 7 into 9 into NC2 and so on, okay, up to n terms. You need to find the value of this. If you remember the values which I have just told you, R NCR, R square NCR, you can directly put in this. How? Just you need to write this in terms of sigma. Now, what is this number? 357. Okay. So 357, you need NCR. So in NCR, okay, let me change something here. I'm just making some calculation easy. This is 1, this is 2, and this is 3. And add one more term, 1 into 3 into NC0, alright? Look at this. So if you write the general term, so it is NCR, which is actually R plus 1th term of this series because it is starting from 0. So what will be the R plus 1th term of this 1, 3, 5, and 6? And that is 2n plus 1. 2n plus 2R plus 1 in terms of R. Make sure it should be R plus 1th term, not Rth, okay? Because you are starting from NC0. If you are starting from NC1, then you need to write Rth term of these numbers, which are in AP, okay? So you need R plus 1th number because NCR is at R plus 1th place. So that will be 2R plus 1. And 357, this will be 2R plus 5, 2R plus 3, all right? 2R plus 3. So this is you are getting, all right? And R starts from 0 to 1. Put 0, 1, 2, 3 in this, you'll get the result, all right? So you can check by putting 0, 1 and 2, all right, whether you have written it correctly or not. Now expand it. After expanding it, you will get 4R square minus plus 6 plus 2, so plus 8R, all right, and plus 3. This is what you're getting, NCR. Now distribute your sigma, so your first term will be 4 times of sigma R square NCR. Then second term is going to be 8 times of sigma R NCR. And third term is going to be 3 into sigma NCR, all right? So you can use these R is from 0 to n, R is from 0 to n, R is from 0 to n, all right? So no problem, just put the values, this and this and this. So I have told you to remember all 3 values. What was the value of R square NCR? It was n into n plus 1 into 2 raised to n minus 2. Okay, so this is the first value plus 8 times of what was the value of this RNCR? It was n into 2 raised to n minus 1. All right, plus what was this value? 3 into 2 raised to n. All right, now you can take common. So 2 raised to n is common. You can see 2 raised to n is common, and what is remaining is 4 multiplied to this is 2 raised to n only. So n square plus n will be remaining. What is this? If 2 raised to n is common, then 4n will be remaining in the second term. And in third term, 2 raised to is common and so 3 will be remaining, right? So this is what you are getting. This is your final answer in simplified form. So it is n square plus 5n plus 3 into 2 raised to n. All right. So this is what you will get. Okay. So in such questions where AP into binomial coefficients, you can use directly those values. It's like memorizing sigma r square, sigma r cube, sigma r, which you have done in sequence and series. All right, so you directly used those values in questions where it was AP into AP, right? Two APs are multiplied because general term of those APs is polynomial in R. So that's the same thing we are doing here also, all right? So if you remember sigma NCR, sigma R NCR, sigma R square NCR, you can use these values. Huh? And if it is with plus minus alternate plus minus sign, then it is going to be 0, whether it is R NCR or R square NCR or R cube NCR. Okay, so this, now let's do some practice. So we'll practice questions based on this, then we will move to some other method, and today we are going to finish it, all right, all kinds of series. So this we have already done, right? This is nothing but sigma r ncr. Okay, so we know this value, this is what we need to remember, all right? So done, right? Now let's move to this. Now you need to answer it. Okay, think about it. Can you do it? Think about it for a moment, then I'll tell you. So proving, we need to prove it. I also have objective questions with multiple options. So we'll do those questions later. First, practice these proving questions. All right. So, Archita, hello. So you can write the general term of this, which is basically if you write the rth term. So NC1, we can see this 1 is multiplied to 2, 2 is multiplied to 3. So if you write R in NCR, it will be R plus 1. All right. That you can compare with this last term also, it is N plus 1 NCR. So just replace N by R. All right. So this is what is written, R starting from 0 to N. And it's the same thing, it's a very easy problem, right? R NCR, distribute the sigma and sigma NCR and put the values. I have told you to memorize these values, so just put the values. Limits are perfect, 0 to n. So in this limits should be, in this second term limit should be 0 to n. In the first one limit should be either 0 to n or 1 to n, both will work, all right? But in second one it should be 0 to n, all right? R should start from 0. So this is n 2 raised to n minus 1 plus this is 2 raised to n, all right? So 2 raised to n minus 1 you can take common and it will be n plus 2, all right? This is your answer. Got it, guys? All right, again a similar question. I think you can do it easily. Just write the general term and finish it. So compared to the question which I have done in the example, these are like baby questions. All right, so I'll write it. Sigma of, if we write the general term and coefficient of NCR, you can see coefficient of NCR can be copied from the last one, all right, which is actually 2r plus 1 in the 1, 3, 5 r plus 1th term of 1, 3, 5. Okay, so look at these numbers. This is an important point only. So 1, 3, 5, but which number you need to write with NCR? R plus 1th number of this sequence. 1, 3, 5. Which number is rth number is 2r minus 1. Do not by mistake write 2r minus 1. This is the r plus 1th place, all right, 2r plus 1. So you need to write 2r plus 1. To write 2r plus 1 NCR, that's the only thing where you can commit some mistake. So just avoid it. R is starting from 0 to n, all right. That is perfect. Then distribute this sigma, so it is going to be 2 times of sigma r NCR, all right, plus sigma NCR. Put the values. So if you put the values, it is going to be 2 into, what is this value, r NCR? It is going to be n 2 raised to n minus 1 plus 2 raised to n. Now they take this 2 raised to n common, so it is n plus 1, 2 raised to n. Fine, got it. Okay, now try this one. This is slightly better. So I want you to do it properly. But do not just put 0 by looking at minus sign, because it is not directly r NCR or r square NCR or r cube NCR, all right? Okay. All right, so let's write the, first write the general term of this 3, 8, 13, and so on. What is this sequence? You can see the difference is 5, difference is 5, okay? So it is 5r, but I'm writing the rth term, okay, rth term. So 5r, if you put 1 in this, it is going to be 5, so minus 2, all right? So in this way you can write, or you can apply the formula of, which formula? AP, formula of AP, okay? So now you can write TR plus 1, because NCR will be multiplied to R plus 1th term of this. So you put R plus 1 in this, so it is going to be, just add 5 in this, so 5R plus 3, all right? So it is minus 1 raised to R, 5R plus 3 and NCR, okay? So simple. Just this is the only thing you need to do carefully. R is starting from 0 to n, all right? Now distribute the sigma, so it is 5 times, take this 5 outside, minus 1 raised to r NCR, all right? R from 0 to n and into R also, and then plus sigma of 3 times of minus 1 raised to R NCR, all right? Now you can put the values. So this value is 0, as I have told you, and this value is also 0. So it is 5 times of 0 plus 3 times of 0. But it is not always 0. Sometimes it might be plus minus 1 also if any term is missing, all right? So write it carefully, write the limits carefully, and then put the value, all right? So final answer is 0. Here we need to prove, but because in competition they are going to ask it uh, in MCQ form, right? Now solve it. Now solve it. This is another series. So I'm giving you very easy series. What is the general term of this? The coefficients, numbers written there. What is the general term of that? Write in sigma form and put the values. That's it. Done, guys? All right, so okay, let me do it. Yeah, Vamsi, right. 4r plus 1 is correct. So that is sigma of, if you write the general term, it is 4r plus 1 and NCr, all right. R from, now it is starting from 1, all right. So you need to write 5, 9, 13, which term? You need to write rth term. That will be multiplied to, NCr, okay, because now it is starting from NC1. So what is the rth term? It is, you can see gap is of 4. So it is 4r, and to match the first term, it should be 1. So 4r plus 1. Or you can use this last term also. So 4 into sigma r NCr, all right, plus sigma NCr, and then put the value. Okay, limits are perfect? No, but not in this. It is r from 0 to, it should be r from 0 to n, but it is r from 1 to n. That is the main point in this. And this is perfect, r from, let me correct. So limits, given limits are basically r from 1 to n and r from 1 to n. All right. So this is perfect. It should be r from 1 to n. So you can write this value. It is what was the value? N into 2 raised to n minus 1. But in the second one, first term is missing. It should start from 0. So NC0 is missing. So first write the total value minus the missing term. So total value is 2 raised to n, and whatever the terms are missing, just subtract those terms from the total value, all right? So it is going to be 2n 2 raised to n plus 2 raised to n minus NC0 is 1, all right? So you can take 2 raised to n common from these two. So this is 2n plus 1, 2 raised to n minus 1, okay? And it's proved. So I hope you have got it, guys. Now this one is a good series. Try this. So this is the first question. We have got a very good sequence. What is this written? Try it. Got it? Okay. See, what is this written? Okay. So count all the C. How many brackets can you see? This is first term. This is second term. All right. Second term is ending with 1. This is third term. Third term is ending with 2. So this will be the nth term because this is ending at n minus 1. So nth term, right? Nth bracket you can say first. So in all the terms or in all the brackets, you can see C naught. C naught is there. So how many times C naught will come? Collect all the C naught. So that will be n times of C naught, n C naught. All right. So if we have collected all the C naught. Now let's focus on C1. So C1 is starting from second term, right? It is there in the third term. It will be there in the all the remaining terms. So C1 will come n minus 1 times because first term does not have C1. So it is n minus 1 and C1 plus. Now C2 will come n minus 2 times because it is starting from third term, and then remaining terms will have C0, C2, but first two term will not, right? So it is going to be n minus 2 NC2 plus 1, all right? So if you write the NCR term containing NCR, that is going to be n minus R NCR, all right? And so on, right? The last term you can write this is going to be n minus 1 times of NC n minus 1 and so on. That NC naught is not there, NCN is not there. So basically what you need to write, if you write this in terms of sigma, then this is nothing but n minus R NCR, all right? R from 0 to n. If you put n, then you can see NCN will be 0, right? So this is what is given in the question. That's a very, very important, right? Obviously, you can distribute and put the values, but let me tell you that if you apply that property, which property? A to B f of R is equal to A to B f of E plus B minus R, all right? If you apply that, then this can be written as this n minus, if you apply that property, this can be written as n minus R, n C n minus R, R from 0 to n, A plus B is n, right? Then further you can write this is nothing but R, and NCN minus R can be written as NCR again. So R from 0 to n. And what is the answer? Answer of this is 2 into n. Oh, answer of this is n into 2 raised to n minus 1. Okay. So this was nothing but RNCR. Is another way of writing this. So you'll get this series many of the occasions. You'll get this series. So n into 2 raised to n minus 1 is the answer. All right. Okay. So you need to remember this. What is this? Whenever you say n minus r, NCR, I mean, do not remember it, but yes, it's a point which you will have to use a lot. I mean, in many questions. In many questions, you'll get NCR, n minus r, NCR. So you immediately you can write r, NCR if limits are from 0 to n, all right? These two are same. This is just the reversed flipped series, all right? They are flipped. Okay, this is if this is starting from NCN minus 1, then this is starting from NC0. All right. The sum will remain same. Sum is 2 into n raised to n into 2 raised to n minus 1. What has happened to me? All right. This was the sum. Okay, now we will begin second type of series in which numbers are there in the denominator. All right. So this series sigma NCR upon R plus 1. All right. R from 0 to n. If you expand it, this is written NC1 upon 2 plus NC2 upon 3 and so on up to NCn upon n plus 1. All right. So this series, see how to find the sum. This is our question. So again, you have that method which I have applied earlier. R n C R is equal to n minus 1 C R minus 1. But this formula we need to redefine by putting R is equal to R plus 1 and n is equal to n plus 1. So if you do that, you'll get R plus 1, n plus 1, CR plus 1 is equal to, this will become n plus 1, NCR. And this cross multiply, I mean divide by this and divide by this. So you'll get n plus 1, CR plus 1 upon n plus upon n plus 1. This is equal to NCR upon R plus 1. So in this way we are going to use the same formula, all right? NCR upon R plus 1. So if it is R here, it should be R plus 1. If it is R minus 1 in the numerator, then in denominator it will be R, all right? 1 extra. Then after applying the formula, R plus 1 will be replaced by n plus 1. This is n. If it is n minus 1, then it will be replaced by n. Okay. And this will become n plus 1. This will become R plus 1, all right? Like, let me apply this here. N minus 1 C R minus 2 upon R minus 1. Can you see that? Can you apply this formula? Yes, you can apply, because you can see this is R and this is R plus 1, right? So you can apply that. After applying the formula, this n minus 1 will become n plus 1. So that is n C. This R minus 2 will become R minus 1, R minus 2 plus 1, all right? Divided by this will be n plus 1. So n plus 1 will be n, all right? In this way you can apply. I hope it is clear, you're getting it. Okay, so let's use it and write the answer. Sigma of NCR upon R plus 1, R from 0 to N. If you apply this formula, you'll get the result immediately. So it is going to be 1 upon N plus 1 in sigma of NCR upon, sigma of, it is going to be now N plus 1 C R plus 1. R is starting from 0 to N. Okay, so now you can see what is this written, N plus 1. You can see that if you put R is equal to 0, this is starting from N plus 1 C 1, then N plus 1 C 2, and so on. So N plus 1 C 0 is missing, right? So N plus 1 C N plus 1. So one term is missing, so it's all right. Write the total sum, that is 2 raised to N plus 1 minus the missing terms, that is N plus 1 C 0, divided by N plus 1. And now the final answer is going to be 2 raised to N plus 1 minus 1 divided by N plus 1. So in this way you can solve it. Right, so I hope you have got it. Now let's start some problems based on this. So this is the first problem you need to solve it. You try it and then I'll tell you how to do it. All right, done. All right. Okay, then let me do it. First, you write the this series in form of sigma. So sigma NCR, always write NCR term of NCR divided by, you can see NC1 upon 2, NC2 upon 3. So it is going to be R plus 1 in denominator. 1 is it is increased, R is increased by 1. So NC2 upon 3, NC3 upon 4. All right. And then you can see 2 raised to 4 with NC3, or these two numbers are same, this number and this number. All right. So it is going to be 2 raised to R plus 1, all right. Now check it, R is starting from 0 to N. In this you need to apply the same formula which I have applied earlier, okay, all right. So it is going to be 1 upon N plus 1. You can apply that formula because this is R and this is R plus 1. There should be a difference of 1, all right. So yes, see, R plus 1 will be replaced by N plus 1. The same formula, exactly same. It is going to be N plus 1, N plus 1 CR plus 1, all right, and this is 2 raised to R plus 1 as it is, all right. Okay, now see how to do it. R is starting from 0 to N. So I haven't all right, can you compare it with this sigma of NCR x raised to R from 0 to N? This is nothing but binomial expansion, 1 plus x raised to N, all right. So you can compare with this, but you just need to compare the powers. compare whether you have all the terms or not. So this is 1 upon n plus 1. I'll tell you how. This is n plus 1 c r plus 1 2 raised to r plus 1. All right. These two numbers should be same. NCR x raised to r. So yes, you have n plus 1 c r plus 1 2 raised to r plus 1. That is perfect. But the only problem is that r plus 1 is not starting from 0, because it should start from nc0 x raised to 0. So n plus 1 c 0 2 raised to 0 is missing. It is starting from, if you put r is equal to 0, if you put r is equal to 0, it is starting from n plus 1 c 1 2 raised to 1. That means first term is missing. So no problem, we will subtract first term. So total sum is 1 plus 2 raised to n plus 1, and the missing term. What is the missing term? N plus 1 c 0 2 raised to 0, which is nothing but 1. All right, divided by n plus 1. So you've got this 3 raised to n plus 1 minus 1 divided by n plus 1. All right, yes, Vamsi, you have got it. You have got it. Nice. Now let's move to another one. Now this has alternate plus minus sign. All right. So it's a similar problem, but the only difference is that it has plus minus sign. So now it is not going to be 0 like we did earlier when numbers were in product. When numbers are in denominator, then this sum is not going to be 0. Then what it would be? 1 upon n plus 1 in this case. Okay. And how to find it? Solve it. You try it first, then I'll solve it. Right, done. So whenever you use this, just write the general term. So it is going to be NCR upon R plus 1. It is all right, and minus 1 raised to R, right? This is what is written here. R from 0 to n. So do the same thing, apply that formula. It is minus 1 raised to R. NCR upon R plus 1 can be written as n plus 1 CR plus 1 upon n plus 1. So that will come out. All right. So that step is same. R from 0 to n. Now this is just series of binomial coefficients, but if you have all the terms, then sum will be 0 because it has alternate plus minus sign, right? You can see that. So total sum is 0. All right, total sum is 0. But you see, if you put r is equal to 0, then first term is missing. Okay, so you need to subtract the missing term with sign. Remember that. So if you put r is equal to 0 in this, so if you put r is equal to 0, this is minus 1 raised to 0. All right, and n plus 1. So 1 minute. Yeah. Actually, no. Let me tell you why. So actually, we'll have to expand it, because in this, the term is starting from n plus 1 c, n plus 1 c1 is of positive sign. All right. So it's better to expand it. If you write it, it is going to be n plus 1 c1 upon 2 minus n plus 1 c2 upon 3 and so on. Okay. So even if you add minus nc0, n plus 1 c0, I'm sorry. N plus 1 c0. All right. So this is positive, then first term should be negative, alternate. Then you'll have to subtract this term in the end. You'll have to add this term in the end. So this is an extra term. All right. N plus 1 c0. We are adding and subtracting. Now this series is complete with alternate plus minus sign. So you can write this as equal to 0. So this value will become 0, and it is n plus 1. And what is this? N plus 1 c0. All right. So n plus 1 c0 is 1. So 1 upon n plus 1. You could directly do this here, but the sign was the important thing. What was the sign of missing term? That we needed to know. So actually n plus 1 C0 which was missing was of negative sign. So we needed to subtract with negative sign, all right? So that's why I wrote this series completely so that you won't get confused, all right? Now this is another series in which, yeah, okay, try this. See how to do it. In this series, one term is missing. Alternate terms are missing. So NC1 is missing, NC3 is missing, NC5 is missing. All right, and you can see the numbers in denominator. So try it, guys. Try it, guys. Try it. Do you know the formula of this? If I write this series NC0 plus NC2 plus NC4 and so on, these are even binomial coefficients, even because of this number, okay, subscript. And then the odd binomial coefficient, these two are same, all right? NC5 is equal to 2 raised to n minus 1, all right? In the beginning you have got two series is NC0 plus NC1 plus NC2 plus NC4 up to NCn is equal to 2 raised to n, and another series NC0 minus NC1 plus NC2. Okay, so using that NC0 minus NC1 plus NC2 minus NC3, right? This was 0. So using this you can say NC0 plus NC2 plus NC4 and so on. These are even binomial coefficients is equal to NC1 plus NC3 plus NC5 and so on, all right? So even binomial coefficients plus is equal to odd binomial coefficient, sum of odd binomial coefficients. And because sum of both is 2 raised to n, so individual sum will be half of that. So that is equal to 2 raised to n minus 1, all right? So you can use it. So in the similar way, there are two ways to solve it, all right? Let me tell you both the ways. So first you write the general term. Okay? You can use what we were doing, like writing this in terms of summation. So how to write it? This is NC 2R upon 2R plus 1. In this way you can write it R from 0 to whatever is the last term. So we don't know the upper limit. Whatever is allowed up to there it will go. All right. So by doing so you can still apply the formula, because you can see this is R and this is R plus 1. So let's apply the formula. So it is going to be replaced by n plus 1, n plus 1, n is n, so it will be n plus 1 in the denominator, and this will become n plus 1, this will become R plus 1, so that is 2R plus 1, alright. So this will become, and R from 0 to, okay, whatever is the allowed limit. If you put 0 in this, now you can see what is this. This is n plus 1 C1 plus n plus 1 C3 and n plus 1 C5 and so on. So odd binomial coefficients, sum of all odd binomial coefficients. So total sum in this case will be 2 raised to n plus 1. All right, and sum of odd binomial coefficients will be 1 by 2 of that, right? This. So it is 2 raised to n, right? 2 raised to n minus 1, because n is n plus 1, so it will be 2 raised to n. So this is 2 raised to n divided by n plus 1. We have got the answer, okay? This is one of the way. I hope you have got it. Then I'll tell you the other way of doing it. So have a look of this problem. What have I done? I've written in this way, general term, then I have applied the same formula, NCR upon R plus 1 is equal to n plus 1 CR plus 1 upon n plus 1 I have taken outside. Now this is sum of binomial coefficients, odd binomial coefficients, in which subscript is odd, and sum of odd binomial coefficient is total sum divided by 2. Total sum will be 2 raised to n plus 1 and divided by 2, so it is 2 raised to n, all right? So I put the value of that. I hope it is clear. Now let's do it using some other way, all right? Okay, so I have we have done two series. One is NC0 upon 1 plus NC1 upon 2 plus NC2 upon 3 and so on up to n plus NC n upon n plus 1. What was the answer of this? If you remember, if you don't remember, then you'll have to do it again properly. Then it was 2 raised to n plus 1 minus 1 upon n plus 1. All right, this was the first question. Let me show you here. So you'll have to do it again if you haven't done it. this is what I have proved. See this was the result, right? So I'm using this result, and I'm also using one more result, this one. Okay, see, look, have a look. This is the alternate plus minus sign. So if I write the second one, that is NC0 upon 1 minus NC1 upon 2 plus NC2 upon 3 and so on. So this is going to be 1 upon n plus 1. If you add these two series, what will you get? You get 2 times of NC0 plus NC2 upon 3 plus NC4 upon 5 and so on, alright, is equal to, add these two, this is going to be 2 raised to n plus 1 divided by n plus 1. If you cancel 2, it is going to be NC0 plus n plus NC2 upon 3 plus NC4 upon 5 and so on. It is going to be 2 raised to n upon n plus 1. Okay. Got it? So this is another way of solving it, but I will prefer if you learn the first one, because that goes direct. No need to remember these two series, all right? If you don't remember, then you'll have to solve these two series first and then you add them. So it's better to solve it in that way. All right? This is another one. Let's see if you can do it now. It's a similar problem. Now you have odd binomial coefficients. All right, let's see if you can do it. Use the method 1. Doing it. Do it, guys, do it. All right, so let me do it now. So write this in sigma form. Sigma of this is a NC1, NC2, all right. So this general term NC1, NC3 will be NC. You can start with 2r minus 1, then you will have to start r from 1, or you can take 2r plus 1, all right. Then you can start r from 0 to n. 0 to not n, but 0 to whatever is the allowed value, right? Like it might be n by 2 or n by 2 minus 1. So no need to write upper limit because it is going up to the all possible terms divided by this. Now denominator in denominator number will be greater than this number, right? 1 greater than this number. So that is going to be 2r plus 2. So again you can apply this formula, NCr upon r plus 1 is equal to n plus 1 cr plus 1 upon r n plus 1, all right? So apply that formula immediately. That is going to be n plus 1 c 2r plus 2, all right, divided by this 2r plus 2 will be replaced by n plus 1. So take this n plus 1 outside. 1 upon n plus 1. Write this sigma. Now this is nothing but binomial coefficients, and binomial coefficients is starting from r is starting from 0 to n. Sorry, not n. No need to write upper limit. All right, 1 upon n plus 1. Now put the values of 0, 1, 2, 3, values of r, so that you can see what binomial coefficients are written in this sigma. So it is n plus 1c 2. It is starting from 2, right? Then n plus 1c 4, then n plus 1c 6, and so on, right? So you have even binomial coefficient, but one binomial coefficient is missing. So if you have all even binomial coefficients, then sum is nothing but 2 raised to n minus 1, that is n plus 1 minus 1. But you'll have to subtract the missing term. So missing term is n plus 1c0. So that is going to be sum divided by n plus 1. Let's take this is equal to I. So this is your I. I hope you've got it. 2 raised to n minus 1 divided by n plus 1. So in this way you can solve it, alright? Got it, guys? Okay, so then this is a series in which you have binomial coefficients as a product, sum taken 2 at a time. So 2 binomial coefficients are in product. Alright. See how to do it. First, let me tell you the shortcut. Okay, so I'll tell you the concept of this. Whenever you have like MCR into NCK, all right? Not NCK, NC R plus K, okay? And sigma, and this is R is starting from say 0. R is starting from 0 and all possible terms, all right? All possible terms. So all possible terms will depend whether n is greater than m or m is greater than m, right? So in that, so all the pairs consecutively, R will start 0, 1, 2, start putting 0, 1, 2, 3. So either this will become n first or this will become m first, all right? So whatever becomes m first, accordingly you can end. Okay, so it might, this upper limit might be n minus k or r minus k. Now what is, okay, so that upper limit, do not worry about that, okay? That you can check that either this will become, this should become n or this should become m, okay, in the end. So there you need to stop. Yes. So it is given, suppose in this question. Then what you need to notice is that this m and n are constant, m and n, and k, this k is also a constant, okay? K is a constant. These are constants, okay? And you can see the difference of these two, difference of R1 and R2. So if it is MCR1 and MCR2, all right, sigma, and R1 minus R2 is a constant, then you can apply this shortcut which I'm going to tell you. So you can see this R plus K minus R is the constant, right? It's nothing but K. So what you need to do is you write this sigma, change one of the NCR using the formula of NC n minus R. So if you change it, it is going to be MC m minus R, right? And keep the second as it is, all right? Second term as it is. Now you can see sum of these two is constant and sum of these two is also constant, okay? So what is going to be the answer? You can directly write the answer in this case. The sum is going to be m plus n c, and if you add these two numbers, it is going to be m plus k. So that is going to be your answer. I'll tell you the logic. This you can apply when all terms are with positive sign. If it is alternate plus minus, then you can't apply this, all right? But if you have all the terms with positive sign, then you can apply this. Let me explain this, all right? What is this actually? So you had this series MC R and NC R plus K, all right? R from 0 to all possible terms. This was required. So what you need to do is you need to expand this 1 plus x raised to n, all right? And when you expand it, so just write nc0 plus nc1x, and I'm going to write those terms in which nck plus 1 will appear. So nck x raised to k, then nck plus 1 x raised to k plus 1, all right, and so on, right? These terms will come. Now the second expansion you need to write is of 1 plus x raised to m. You can see m is there, so MCR will get in the expansion of 1 plus x raised to m. But remember, in one of the expansion you need to write the expansion in increasing order of power of x, but in other expansion you need to write the expansion in decreasing order of powers of x. So how to do that? You just write 1 plus x as x plus 1. That's it and done. So if you write like this, it is going to be mc0 x raised to m plus mc1 x raised to m minus 1 plus mc2 x raised to m minus 2 and so on. Okay, if you multiply this first and second equation, all right, first and second equation, then you can see how where this term is going to be coefficient of x raised to something. See how, see if you multiply these two, this bracket as well as this bracket, this first term will be multiplied to all the terms, then second term will be multiplied to all the terms, then third term will be multiplied to all the terms, right? You see, when this first term of second bracket will multiply to this, what would you get? You get mc0 into nck, that is the first term, mc0 nck plus mc1 nck plus 1, then mc2 nck plus 2, right? So that will be basically this is nothing but coefficient of, check this, k and m plus k, right? Coefficient of x, m plus k. Now what is this term? This term, if you can see, is basically, now it is next nc k plus 1 when will be multiplied to this. If you multiply these two terms, then you'll get this term, right? And again you can see now in the next term of first bracket, power of x is increased by 1, and in the second term of second bracket, power of x is decreased by 1. So overall when you will multiply, you'll get again x raised to m plus k, right? Are you getting this? And if your third term will be multiplied to this, then again you'll get x raised to m plus k. So this whole thing is nothing but the power of unit. So this sigma mcr ncr plus k is coefficient of x raised to what? Coefficient of x raised to m plus k in the product of these two. So that is 1 plus x raised to n into 1 plus x raised to m. Now you can write 1 plus x or x plus 1, doesn't matter. That means you need coefficient of x raised to m plus k in the product of 1 plus x raised to m plus n. So can you see this m plus n is added, and that m plus k is added by making the powers of x in decreasing order. What we did in by writing mcr is equal to mcm minus r. That's why I have written mcr is equal to mcm minus r. So you can see that these coefficients, see, this is coefficient of x raised to r in the expansion of 1 plus x raised to n, and this is coefficient of x raised to r minus k. So when I wrote this m minus r, it became the coefficient of x raised to m minus r, and this is coefficient of x raised to r plus k. Then I check this, if this sum is constant, then that means for any value of r, it is going to be the coefficient of x raised to sum of these two, and sum of these two is a constant. That means it is coefficient of x raised to m plus k in the product of these two expansions. So that we got, that we get easily. So we are using that shortcut. In this general term, if you write tr plus 1, that is going to be 1 plus, that is going to be m plus n cr x raised to r. This r is nothing but m plus k. So your answer is m plus n c. What was required? M plus k. So m plus k. All right. This is the answer. I hope you got it. Right, so we use this. But if there's alternate plus minus sign, then you can't use it. Okay, so anyways, let's use it whenever you have all positive terms. So write the answer of this. See if you can write the answer. So when all the terms are positive, let's learn it, how to apply it. Then for negative, what to do, we will do it. So this is what NCN. So N is same, NC0, NCR, and NCR plus 2, right? You can see difference is constant. Okay, so immediately R is starting from 0, and you can see now it is going up to n minus 2. So whenever n is defined, you can write the last term also. So what you need to do is you need to change one of these two, one of the two binomial coefficients. So write it NC n minus r, NC r plus 2. Now you can see this sum is constant, this sum is constant, and we have all possible terms. So write the answer. N plus n is 2n, C, sum of these two is basically n plus 2. So n plus 2. And it is written in expanded form, so it is right at 2n factorial divided by n plus 2 factorial, and 2n minus n plus 2 is n minus 2 factorial, right? That is going to be answer. Got it? So in this way you can apply it. Now see this, how to do this. Again write in sigma form. So sigma of this NCR and n plus 1C. This is going to be what? R plus 1? Yeah, R plus 1. R is starting from 0 to n. Okay? You can check it. You can check it. So you can see this difference is constant. All right. So again change it. So write NC n minus R and write this n plus 1C R plus 1 as it is. All right. R is starting from 0 and n. So now this sum is constant. This sum is n plus 1 and this sum is 2n plus 1. So it is going to be 2n plus 1 C n plus 1. All right. So that is your answer. So this is 2n plus 1 factorial divided by n plus 1 factorial, and 2n minus n plus 1 is n factorial, right? This is your answer. Okay, now let me tell you one important series which you need to remember. If this is a series which you need to remember, sigma NCR the whole square, all right, R from 0 to n. This value is 2NCN. Okay, I'll prove it easily, and you can prove it easily. See how to prove it? It is like this. It is written NC sigma of NCR into NCR, which is NCR square. So now you can see difference is constant, 0. No problem, but whatever is the difference is, R is starting from 0 to n, all the terms you have. So change one of the binomial coefficient by using the formula NCR is equal to NCN minus R, and NCR, R from 0 to n. Now you can see this sum is constant, this sum is n, and this sum is 2n. So hence we got the answer using the same trick, 2NCN, alright. So this is the answer. If NC0 square plus NC1 square plus NC2 square up to NCN square is nothing but 2NCN, and you need to remember this series, alright. This value you need to remember. So now solve it, okay, this one. This is not pretty straightforward. You have some numbers in multiplication as well. So you try it. You try it first, then I'll tell you. All right, so let me do it then. No? Let me see if okay. So voice is perfect. So if I write the general term, then this is going to be R into NCR square. All right. R is starting from 1 to n. So first, what you need to write for what you need to do is remove this R. Okay, that is our problem. So how to remove that R? I told you that this formula is very important, R NCR, because everywhere you can't use differentiation or any other thing. Yeah, you can use that summation wala property. That you can use NCR R from 1 to n. But because in this, yeah, you can even make the limit 0, right? So R NCR, use the formula. So this is going to be sigma n, this is going to be n minus 1 CR minus 1 n NCR. Now you can see this sum is constant and this sum is constant. This difference is constant, the numerator means sum is constant. R from 1 to n. So change one of the binomial coefficient and apply that logic. So now this sigma, it is n minus 1 CR minus 1, and I'm changing the second one. So NC n minus R. So now you can see this sum is constant. This sum is n minus 1 and this sum is 2n minus 1, right? So what is the answer? 2n into 2n minus 1 c n minus 1. This is going to be our answer, all right? But it is given in expanded form, so put the value of NCR. So there's 2n minus 1 factorial divided by n minus 1 factorial into 2n minus n minus 1 is basically n factorial, right? So if we cancel this n, it is going to be n minus 1 factorial, all right? So you can write your answer in this form: 2n minus 1 factorial divided by n minus 1 factorial, the whole square, all right? So that is your answer. I hope it is clear. So I'll tell you one more series. If it is with plus minus sign. So suppose if you have this one, NC0 square minus NC1 square plus NC2 square minus NC3 square, all right, and so on. So now you have this NCR square with alternate plus minus sign. Okay. So see what is the answer of this. How to get this series? It is if you write in sigma form, it is sigma of NCR square and minus. Okay, so R is starting from 0 to n. This is what you have. So okay, I'll write one of the expansion of 1 minus x. I'll have to write this time. So always write two expansions and multiply those two expansions, and you'll see that this is going to be the product of this is going to be coefficient of 1 of x raised to something, all right? And actually you know what is that x raised to power, that you can write, that you'll get to know by writing it NCR NC n minus r. So you can see this sum is still n, so it is going to be coefficient of x raised to n in the product of which two expansion. In this one expansion is 1 minus x raised to n, so let's write it NC0 minus NC1 x plus NC2 x raised to 2. So this will give you the hint, all right? At least you can use this, that you need to figure out the coefficient of x raised to n in the product of which two expansion, 1 minus x and the other is 1 plus x. Basically in that you'll take x plus 1, because one of the expansion you need to write in increasing power of x and other expansion you need to write in decreasing power of x, all right? So minus nc 3x raised to 3 and so on. Leave it now. Now write second expansion x plus 1. Why have I taken this minus sign? Because I'll get alternate plus minus sign. In the required series, it is alternate plus minus. That's why I have taken 1 minus x. If it was all the terms would have been positive in this, then I would have taken 1 plus x, all right? In that case, actually, we applied that shortcut. So it is going to be nc0 x raised to n plus nc1 x raised to n minus 1 plus nc2 x raised to n minus 2 and so on. Now, as I told you, you need to look for the coefficient of x raised to n, or you just look for these terms, you'll get to know. So nc0 will be multiplied to nc0. You see nc0 is square and it is coefficient of x raised to n. If you multiply these two, it is nc1 square with minus sign, exactly what you need you're getting, all right? And again, it is going to be x raised to n minus 1. So if you multiply these two expansions, you need coefficient of x raised to n, okay, in this 1 minus x raised to n and 1 plus x raised to n, all right? And what is that coefficient? That coefficient is nothing but this series, all right? This series is coefficient of x raised to n. Now the main job is how to find the coefficient. Let's see. So we'll write 1 minus x square whole raised to n. We need coefficient of x raised to n in this. Coefficient of x raised to n in this. Okay. Now if you write the general term of this tr plus 1, it is going to be minus 1 raised to r ncr x square raised to r, so 2r, all right? This 2r should be n, so r should be n by 2, but n by 2 will be an integer. Will it be an integer? It might be if n is an integer. If n is not an integer, then n by 2 will not be an integer. That means r will not be integer, but r should be an integer. That means that term does not exist, all right? So we have got the answer, okay? We need to put r is equal to n by 2. So this series is going to be equal to either minus 1 raised to, put r is equal to n by 2, nc n by 2, but when will this answer exist? When n is an even number, all right? And 0 when n is an odd number. Okay, so we have got two answers. Understood this? Have a look, then I'll give you one example to solve. All right. See, if I ask you this, what is this answer? 20c0 square minus 20c1 square plus 20c2 square and so on. Okay, so you can apply that formula, and answer of this going to be, what was the answer? Answer was n minus 1 raised to n by 2. So what is n? N is 20 by 2 and n c n by 2. All right, that was the answer. You can apply that when n is even. So yes, n is even. So this answer is going to be 20c10. All right, 20c10. If I give you this 25c0 square minus 25c1 square plus 25c2 square and so on. Okay, you again apply that formula. If you apply this formula, minus 1 raised to 25 by 2, 20c 25 by 2, then that 25c does not exist, right? It should be an integer. So by the logic, that means this does not exist. You can answer 0. You can write the answer as 0. So 0. Now suppose you have say 22c0 square minus 22c1 square minus plus 22c2 square. Why am I writing this? What is different in this from the first one? See what is different. Minus 1 raised to, it is going to be 22 by 2 and 22c 22 by 2. I just wanted to show you that answer might be negative also, right? So this was positive and non-zero. This is now negative and non-zero. So it is minus 1 raised to 11, which is minus 1, and it is going to be 20c11. All right. All right. Have you got it? So this was the sum. Okay. So I'll continue. I'm taking a break here, and after that, I'll continue. After some time, I'll continue the series today only. All right. Remaining series will practice. We'll continue practice on that. Okay. So you also take a break, and we'll continue practice session then.